Today we're going to take the information that we've been talking about as far as enthalpy changes, and we're actually going to graph it. And you are going to see in the next few minutes here that exothermic and endothermic reactions, when they're graphed, look very, very different from one another. So we're going to take this particular reaction here, where we take ethanol and react it with hydrogen gas to come up with ethane and water vapor. And if you graph this so that your energy is on the y-axis, and we just call this the reaction coordinate on the x-axis. What the reaction coordinate means is you can almost think of it in terms of time. If I look at this point right here, the reaction has not yet started, and then the further I go along here, the further the reaction is as far as how it is proceeding, and then when I get all the way over here, the reaction is completed. So the reactants here are my ethanol and my hydrogen, and they have a level right at 100 kilojoules, and you can see that right here with where that lines up on the y-axis. The products, the ethane and the water, are at a level here. So if I wanted to calculate the delta H for this reaction, what I would do is if I kind of took this and kind of shoved it over this direction so you can see where it would line up along the axis. The distance from here to here is your delta H. And so the delta H for this reaction is going to be the energy of the products, which is 50 kilojoules, minus the energy of the reactants, which is 100 kilojoules. And so that is going to give me a delta H of a negative 50 kilojoules. So that means that this particular reaction is going to be exothermic. Okay. Now you'll also notice that there's a little hump right here, and most reactions, in fact I think all reactions, have to have a little bit of energy added to them just to be able to get them going. So like for example, you know that I think the example that your author of your book used was that you know that paper burns, but you have to actually apply a match, apply some energy to that in order to get that reaction to go. It doesn't happen just because there's oxygen in contact with the paper and cause it to burn, which is good because we wouldn't have any books if that was the case. So you have to add a little bit of energy in order to get the reaction to get started. So the distance from here to here is your activation energy. And so this is going to go, looks like about 135 kilojoules. So my activation energy here is going to be approximately 35 kilojoules just to get the reaction going. Okay, so again, to sum up, the difference in energy between your reactants and your products is your delta H. Remember that you always take products minus reactants in order to find that. And this distance here is the energy that it takes in order to get the reaction going. Now, this one is for an exothermic reaction. But if you're looking at an endothermic reaction, the coordinates look a little bit different. Okay, or not the coordinates, but the graph looks a little bit different. So on this particular graph, you can see here that, again, just like I had on this side, I don't have a specific reaction for you to look at, but your reactants are going to be here, and your products are going to be here. And so if I look at this here, the delta H is still going to run in between, or it's going to be the difference between my products and my reactants. So if I would extend this over here, then the distance from here to here is going to be my delta H. And as you can see here, the products are higher than the reactants. So this delta H is going to be a positive number as opposed to this one where it was going to be a negative number. And so as we've already learned, a positive delta H is going to be an endothermic reaction. And you can also see on this particular graph that the activation energy that's going to be required for this particular reaction is very, very high. So here's your activation energy. Huge amount of energy required to get this reaction started. So basic shape as far as delta H and activation energy is the same between the two, but you can see that here your reactants are higher than your products, whereas in an endothermic reaction, your products are going to be higher than your reactants. So that is going to be how you are going to analyze an energy diagram for a reaction.